In section 2.5, we're going to look at what to do to solve equations when there's variables on both sides. Again, just like last section and pretty much this entire chapter, this should just be a review from when you had it with Mr. Newton. So let's get started. When I first look at this problem, I see the parentheses. So I always want to get rid of the parentheses first. So I'm going to take the 9 times the 2 and the negative 3x. So I would have negative x minus 2 equals 18 minus 27x plus 6. Now when I look at this, I want to make sure that I have all like terms combined on individual separate sides of the equal sign. So when I look at the left side, negative x minus 2, there's nothing to be combined. But on the right side, I see the 18 and the 6, and then the negative 27x is just going to stay as it is. So let's combine like terms, and again, you do it on individual sides of the equal sign. So 18 plus 6 is 24. Minus 27x. I could have written that as negative 27x plus 24 and it would have still been the same. So now you can see that there's variables on both sides of the equal sign, and what our goal is to move variables to one side and the constant terms, so just the numbers, to the other. And it does not matter which side you put which. So I could put the x's on the left and put the constant terms on the right, or vice versa. I could put the x's on the right and the constant terms on the left. It's just up to you. In this case, I see that if I add this 27x over from the right to the left, I'll end up with a positive number in front of my x term, which, again, it doesn't matter. I just kind of like when things end up being positive, so that's usually what I do first. So in this case, I'm going to add the 27x from the right to the left. I'll add it to the negative x since those are like terms. Keep in mind that there's actually an implied negative 1 in front of that x, so negative 1x plus 27x would be 26x. And I still have the minus 2 equals 24, since the negative 27x plus 27x would give me 0. Now I'm going to add this 2 from the left to the right. Negative 2 plus 2 is 0. That's where it cancels right there. So I'm left with the 26x on the left and 26 on the right. And of course, divide both sides by 26 to get rid of that multiplication of 26. And 26 divided by 26 is 1. As always, you can take this answer of x equals 1 and substitute it back into your original problem and see if it works out. Let's look at another example. So here again, I see some parentheses. So the first thing I want to do is distribute to get rid of those parentheses. So 2 times 6x is 12x, and 2 times negative 1 is negative 2, minus 3x equals 9x plus 8. Once I've taken care of those parentheses, I'm then going to look at individual sides of the equal sign and see if I can combine like terms. So in this case, I see the 12x and the negative 3x, so I'll combine that to be 9x. That minus 2 stays where it's at, and I have 9x plus 8 on the right. So I'll now move variables to one side and everything else, the constant terms, to the other side. So I'm going to subtract this 9x, but look what happens. 9x minus 9x is 0. 9x minus 9x is 0. So I'm left with just negative 2 equals 8. Whenever your variables cancel out like this and you end up with a false statement, negative 2 does not equal 8, that means that there is no solution. So what that means is there is absolutely no number under the sun, no real number, that if I substitute back into my original equation, it would give me a true statement, meaning there's no number I could substitute into x on this side, and that same number substitute in for x on the right side, that'll make the left equal to the right. So here again, the answer is no solution, meaning there is absolutely no number that will work for x. Let's look at one last problem. I see again that I have parentheses here, so I'm going to distribute, not just on the left, but I'm also going to distribute on the right. So 3 times 8x is 24x, and 3 times 2 is 6. And then on the right side, I have 10x plus 2 times 7x is 14x plus 6. So just like before, now I'm going to look at individual sides of the equal sign and see if I can combine like terms. There's nothing to combine over on the left side, but on the right side I see 10x and 14x, which can be combined. So this is just going to be written down again on the left. 24x plus 6 equals 10x plus 14x is 24x plus 6. So you already see something weird's happening when I have the left exactly the same as on the right. But look what happens if I just keep carrying on here. I would subtract 24x from both sides, try to get variables on one side, constant terms on the right. But again, this is going to cancel on the left, and this is going to cancel on the right. So I'm left with 6 equals 6. So this time, my variables cancel each other out, and I was left with a true statement. 6 is equal to 6. And so what this means is that I could substitute any number in for x on the left side and any number in for x on the right side, and it would work every single time. So my answer in this case is all real numbers. So if you remember, that's the symbol to represent any number in the real number set. All real numbers, the double bar R. So again, this literally means that I could substitute any number in for x on the left and that same number on the right for x, and it will give me a true statement. Any number you can ever think of would make this, the left side, equal to this, the right side. So all real numbers. This is exactly a polar opposite from the previous example where it was no solution, meaning there was absolutely no number that would work. In this case, every number would work to make this equation true. Just like always, make sure you jot down any questions that you have that you can bring to class so we can cover those before you guys tackle your homework tomorrow in class. We'll see you then.